Hello everyone. So today on this video, I'm gonna show you how to solve some systems, some examples of system of linear equation. And as we know that there is three, if we want to solve system of linear equation, there is three methods that we can use. So there is one, we can use substitution methods, elimination methods, or geometrically method. So on this video, I'm just gonna focus on solving system of linear equation using substitution method. So what substitution method means is that you write one variable in terms of another variable in one of the equation, and then once you find the value of that variable in terms of the other variable, you substitute it on the second equation, and then you end up having only one to solve for only one variable. And using this probably will sound a little complicated, but once we do an example, you'll see what I'm talking about. So let's say we have this example here. So we have 3w plus z equals 15, and the second equation is w plus 2z equals 10. All right. So this is equation number one. Okay, 1 second. So this is equation number one and equation number two. All right. So let's solve for z in the first equation. So let's solve for z in the first equation. So we have z equals 15 minus 3w, because we want to find the value of z, so we have to subtract 3w in the first equation on the left side on the first equation, and then we do the same thing here on the second equation on the right side. So we get z equals 15 minus 3w, and so this becomes our first equation. The second equation stays the same, so we get w plus 2z equals 10. Now that we have z written in terms of w, what we can do is we go ahead and substitute z on the second equation. Substitute 15 minus 3w for z in the second equation. So that's what we're gonna do. So let's say, so leave the first equation the same, z equals 15 minus 3w. Now we have w plus 2, and what's z? 2 times z, what's z? Z is 15 minus 3w equals 10, right? So let's go to the other side. So we get z equals 15 minus 3w. And now we're just gonna solve for w on the second equation. So we have w plus, we have 2 times 15 minus 3w, which is inside the parentheses. So we have to distribute 2 into 15 and minus 3w. So we get 2 times 15, that's 30. 2 times negative 3w equals negative 6w equals 10. So the first equation stays the same. I mean z. So we're right. Z equals 15 minus 3w. Now we get, so we have w minus 6w. So that's a minus 5w. Minus 5. Let's erase this. So we get a minus 5w plus 30 equals 10. Again, leave the first equation the same, so 0 get 15 minus 3w. So we have minus 5w plus 30 equals 10. Now on the second equation, so we want to get rid of this 30 on the left side. So what we have to do is we have to subtract 30 on the left side and then do the same thing on the right side. So we get minus, and once we do that, we left with minus 5w on the left side. It equals 10 minus 30, and leave the first equation the same, 15 minus 3w. So we get minus 5 W equals minus 20. Now let me erase this. I'm gonna leave the system of linear equation that I have. I'm gonna leave it like it is, and then I'm just gonna erase this, and then I'm gonna continue on this side, on the left side. So now we get Z. So we get Z equals, I'm insisting of writing the first equation so we know that we're solving this. This will remind us that we're solving a system of linear equations. So I have to write the first equation. I have to keep writing the first equation. So we get minus 5W. So here minus 5W equals minus 20. So here we have we want to get rid of this minus 5, and we have a multiplication. So what we can do is divide by minus 5. We do the same thing for both sides. We divide by minus 5 on the left side and on the right side. So we get W equals minus 20 over minus 5. That's again minus a negative number divided by a negative number. So it's going to be a positive. And then we have 20 divided by 5. That's 4. So now we find what W is. So W equals 4, right? All right, so now what we can do is we substitute 4 for W in the first equation. So remember, this is the first equation. So we go back to the first equation and we substitute 4 for W. So we get Z equals 15 minus 3 times W, which is 4. And so we get W here equals 4. Don't forget to write that down. All right. So let me continue here. So we get, there is more. All right, 1 second. Okay, so we get Z equals 15 minus 3 times 4, that's minus 12. And here we get W equals 4. And so we get Z equals 15 minus 12, that's 3. And W is, I don't know, we said that W is a 4. All right, so this is our answer. We change the color here. So Z equals 3 and W equals 4. So the pair Z and W is the solution of this system of linear equation. So Z, W, let me write it down here so you know. So the pair ZW, which is 3, 4, is the solution to the system of linear equation. And if we want to make sure that this is correct, all we can do is, the only thing we're gonna do is substitute 3 for we go back to the original system of linear equation, and then we substitute 3 for Z and then 4 for W and both equation, and see if it satisfies, if this pair satisfies this so let's do that. Let's do that just for this example. Okay, so let's go back to original system of linear equation. So we get 3. So we get 3 times W, which is what? W is a 4. So we multiply by 4 plus Z, which is 3, and we want to see if that equals to, I have a question mark here because I don't know, so I'm going to see if that equals to 15. And then I'm going to do the same thing for the second equation. So I have W, which is 4, plus 2 times Z, which is 3, and I'm going to see if that equals to 10. So we get 3 times 4 is 12, plus 3, and yes, that equals to 15. And we have 4 plus 2 times 3, which is 6, and yes, that equals to 10. And that's it, and that's how you make sure that your answer is correct. Just go back and substitute for both variables the value for both variables and see if that satisfies both equations. So let's do another example. So let's do another example. In 1 second, I'm gonna erase the board. All right, so yeah, just 1 second. Maybe if we do more examples, you will understand. All right, so let's do another example. So hold on 1 second, let me see. Let me get another example here. So let's say I have, and by the way, both variables can be, usually we work with X and Y, but the reason why I'm using W is Z, so I can show you that we can use different variables. It doesn't have to be X and Y all the time. So this time let's use X and W. Let's see. I mean, let's use X and Y. So let's say we have x plus 6y equals 32, and x plus 3 times y equals 17. All right, so here we have another example. So let's say, so as you can see here, we have we always try to find, we want to make it easy for us. To make it easy for us, if we want to solve for a variable, we're gonna look at our system of linear equation and see which equation, which variable that is easy to solve for. And here both equations, as you can see, it's easier to solve for x. So let's solve for x in the first example, on the first equation. So we get x equals, here we have x plus 6y equals 32. So what we can do if we want to get rid of this 6y, so we have to minus 6y here on the left side, minus 6y on the left side. We do the same thing here, minus 6y on the left side, and we get x equals 6y. With 6y we cancel out, and we get 32 minus 6y. This is our first equation. Second equation is x plus 3y equals 17. All right, so now that we have x written in terms of y, so what we can do is, again, we do the same thing as first example. We go back and substitute 32 minus 6y for x on the second equation, and then solve for x. All right, so let's do that. So here, my first equation, second equation. So I'm gonna leave my first equation the same, x equals 32 minus 6y. So now I'm gonna go ahead and substitute x, 32 minus 6y for x. This time let's use a different color. Let's use yellow. So let's say x is what? 32. No, it's not good. Okay, let's just use blue. So let's okay, so I get 32, x is 32 minus 6y. So this is my x. It's 32 minus 6y and plus 3y plus 3y equals 17. All right, so this is all right, so I'm just gonna go ahead again. I'm just gonna write my first equation. It's not gonna be changed. X equals 32 minus 6y, and then on the second equation, I'm gonna solve for y. So I have 32 minus 6y plus y. That means I have 32 minus 5y equals 17. All right, so I'm gonna leave my first equation the same. I'm insisting of leaving of keeping right in the first equation, so you don't forget that we're solving a system of linear equation. So we get 32 minus 6y. So here I have 32 minus 5y equals 17. Now I want to solve for y on the second equation. So what I'm gonna do is first I have to get rid of this constant, which is 32. I have to subtract 32 on both sides because the inverse operation of addition is subtraction, and I'm gonna do the same thing here on the right side, and I'm gonna get minus 5y equals 17 minus 32. All right, so let's keep going. All right, x equals 32 minus 6y. So here minus 5y. First, I'm gonna simplify the right side. 17 minus 32. That's 17 minus 32. So we get 3, that's a 15. All right, that's minus 15. Don't forget that we have a negative sign here. I mean, negative 32 is great. 32 is greater than 17. That's why I have to, and the sign of negative of 32 is negative. So I have to keep that negative, and I get negative 15. So I'm just gonna go ahead and erase this. All right, just 1 second. All right, so I'm gonna write my equation. I'm gonna write my first equation. I'm gonna leave it as it is. X equals 32 minus 6y. So here I have minus 15y, minus 5y equals minus 15. So here I have a minus 5 is multiplied by y, and I want to get rid of that minus 5. So what I'm going to do is I'm going to divide by minus 5 on the left side. And what I do to the left side, I have to do it to the right side because this is an equation. And I get y equals minus 15 divided by minus 5. First, I'm going to have a positive sign, and 15 over 5 is 3. So now I got my y. Now I'm going to go ahead and substitute 3 for y and the first equation. So I can solve for y. So I can find what the value of x is. So I'm going to go ahead again. I'm going to leave my first, this is my first equation. So I'm going to substitute 3 for y in my first equation. So I get x equals 32 minus 6y, and y is 3. So I have y equals 3. Now I'm going to just keep solving for x on the first equation. So I get x equals 32 minus 6 times 3, that's 18, and 32 minus 18, that's 32 minus 18, that's 14. So I get x equals 14 and y equals 3. And this is my my solution to this system of linear equation. So let me write it down in a different color. So I get, so x equals 14 and y equals 13. So the pair x, y, which is 14, 3, 14, 3 is the solution of the system of linear equations. So, and again, like I did for the first example, you can actually go ahead and to the original equation and substitute 14 for x and 3 for y, and see if that solves, if that satisfies the both equations. I'm not gonna do that for this example. So I'm just gonna go ahead and do another example. So again, let me raise this board here. Okay. So I'm gonna keep using x and y as variables, but again, you can get different variables in your exam or homework. So it doesn't have to be an x and y. It could be u, w, y, z. I'm just gonna go ahead and write another example. So here I have used a different color. Let's use green this time. Okay. So let's so I have 3x plus 4y equals 33, and I get 6x plus 3y equals 36. first equation to second equation. So here I'm gonna look again. I'm gonna look at my system of linear equation and see what's the best variable to solve for. So here I don't have really the best variable to solve for, but I'm just gonna go ahead this time. I'm gonna solve for y first. I'm gonna solve for y first, and I'm gonna do that in the second equation. So I'm gonna go ahead and do that for the second equation. Now since this is like my third example, I'm not gonna keep writing the first equation, so I'm just gonna go straight ahead so I can save some space. I'm gonna go straight ahead and to the second equation and solve for y, but don't forget that we are solving for system of linear equation here. Okay, so here I got let's use the different color here. All right, 1 second. So here I'm gonna go ahead and solve for y in the second equation. So what's my second equation? Second equation is 6x plus 3y equals 36. So if I want to solve for y, I have to get rid of this 6x on the left side. So I'm gonna minus 6x on the left side, and what I do to the left side, I have to do it to the right side because this is an equation. So minus 6x, and then I'm gonna get 3y equals 36 minus 6x. And I'm gonna get y. I have to get y, but I have to leave y on the left side by itself, and I have 3 multiplied by y. And what's the inverse operation of multiplication? It's division. So I'm gonna divide by 3. And since this is an equation, what I do to the left side, I have to do with the right side. So again, I'm gonna divide by 3 on the right side as well. So I get. And remember, I'm just working on the second equation here. Okay, so I'm gonna go ahead. So 3y divided by 3 is just y equals 36 divided by 3 is 12 minus 6x divided by 3 is minus 2x. All right, so now I have y written in terms of x. So what I'm gonna do now, I'm gonna go back to my first equation, and then I'm gonna substitute y 12 minus 12x for y in the first equation. So let's do that. Okay, so let me erase this. Okay, so, and remember here I'm working on the first equation, so I'm gonna go ahead and substitute for y. Okay, so I get 3x plus 4y. So let me write the equation first. 4y equals 33. Right, so get 3x plus 4 times, what's y? Y is 12 minus 2x. And that equals to 33. So now I'm going to simplify this expression. So I get 3x plus, here I have 4 times, I have to distribute 4 to whatever I have in the parentheses. So 4 times 12 is 48 minus 4 times 2, that's a minus 8x. And don't forget that I have that equals to 33. Okay, so I'm gonna combine like terms. So here I have 3x and minus 8x. So that's a minus 3x plus 48. That equals to 33. All right, so let me keep solving, continue. All right, so again, minus 3x plus 48 equals 33. And I want to get rid of this 48 over here. What's the inverse operation of addition? It's subtraction. So I'm gonna again subtract minus 48 here on the left side. Do the same thing for the right side, and I get minus 3x equals 33 minus 48. And here I get, I'm gonna leave this minus 3x, and now simplify the right side. So 33 minus 48. So let's do that. So so at first it's gonna be a negative because 48 is greater than 33. So let's do that without using the calculator. So let's do this. So 48 and then subtract 33. So 8 minus 3, that's a 5. 4 minus 3, that's a 1. So that's 15. So minus 15. And here I have minus 3 times x equals minus 15. Here I have multiplication, and if I want to get rid of that minus 3, I have to divide by minus 3, and the same thing for the right side, divide by minus 3, and then I get x equals minus 15 minus 3. And remember, when I divide a negative number by a negative number, that's a positive, and 15 divided by 3 is just 5. All right, so now I get x equals 5. So now I'm gonna go ahead, I'm gonna go back to second equation, and then over here in the second equation here, either we go back to the original second equation, or I go back to this one here, and then substitute 5 for x, and then solve for y. All right, so let's do that. All right, so for second, our second, let me change the color here. Let me change the color. So let's use green. All right, so my equation is y equals 12 minus 2x. So I'm gonna go ahead and substitute 5 for x. So I get 12 minus change the color. So you know that I substituted 5 for x, so I get 5. Oh yeah, don't forget that I have a 2 here. 2. So I have 2 times 5. And then I get y equals, so let's simplify. So I get 12 minus 2 times 5, that's a minus 10. And then y equals 12 minus 10, that's a 2. So now my x is 5, x equals 5, and y equals 2. So again, I'm just gonna write the pair x and y, x and y, which is 5, 2 is the solution to this system of linear equation. And again, you can go back, you can take this, you can go back to the original system of linear equation that I have, and then substitute in 5 for x and 2 for y, and then see if that satisfies the system of linear equation. And that's how you check if your answer is correct, but I'm not gonna do that here. So I'm just gonna go ahead and do another example. This probably will help you in your homework or your study for an exam, or if you're just curious about how to solve system of linear equation using substitution method. Right, so the more examples you do, the easier it will get for you. The more examples you do, the easier it will get. All right, so let's do another example, and this will probably be the last example. So it's so here I get 2. So let's use a different color. Again, let's use green. So let's say I have 2 times x, 2 times x plus y equals 13, and x plus y. I actually should start with this example. It looks an easy example. X plus y equals 8. Again, this is my first equation. This is my second equation. So, and like I said earlier, I'm gonna take a look at my system of linear equation and see which variables it's easier to solve for. And here, as you can see, I get the second equation. It's easier to solve for either x or y. So I'm just gonna go ahead and solve for x this time. So what I'm gonna do is, again, I'm not gonna write the first equation. I'm just gonna work on this second equation. So I get, let's use a different color. So let's say, okay, so I have x plus y equals 8. So I'm gonna solve for x. So if I want to solve for x, I have to get rid of this y, so I'm gonna minus y because the minus is the negative, is the inverse operation of addition. And what I do to the left side, I have to do it to the right, to the right side. So I'm gonna minus y, and then I will get x equals 8 minus y. So now that I have x is written in terms of y, I'm gonna go back to, let's say, my first equation, and then I'm gonna substitute 8 minus y for x, and then solve for y. So let's do that. So this is the first equation here. So I get 2x plus y. Let me write it first, equals 13. Now I'm gonna substitute 8 minus y for x. So I get 2. Let's use a different color so you see what I'm doing here. So I get 8 minus y. Go back to blue, plus y equals 13. So I have to distribute 2 to whatever in the parentheses. So 2 times 8. So 2 times 8, it's 16, minus 2y plus y equals 13. So now I'm going to combine like terms. So I'm going to leave 16 minus 2y plus y is just minus y equals 13. And now I want to solve for y, so I have to get rid of this 16. So I get a minus 16 on the left side, subtracts 6 minus 16 on the left side, and do the same thing on the right side. And then I get minus y equals 13 minus 16. All right. Okay, so and I get and I'll get minus y. So it's simplify the left side. So minus y equals 13 minus 16. So we get minus y equals 13 minus 16 is a minus 3. And then here I want to solve for y, and I have negative y, negative 1 times y. So I have to subtract. I have to divide by minus 1. I'm doing these steps so you can see what I'm doing. So I have to divide by minus 1. So I get y equals 3. Now that I have my y, so I'm gonna go back to the second equation and then substitute 3 for y and then solve for x. That's what I'm gonna do here. I hope I'm not going fast. I'm going fast in the last 3 examples because I think that now you know what I'm doing, like the steps I'm following. So I'm just gonna go back and to my second equation, substitute 3 for y. So I get x, let me write the equation first, plus y equals 8. Now I have x plus, let me use a different color so you know what I'm doing. So plus y is 3. Let's go back to blue. Equals 8. So x equals, I'm gonna subtract 3. Left side does the same thing, and I get x equals 8 minus 3. That's a 5. So x equals 5. So the solution is y equals 3 and x equals 5, or the pair x y equals 5, 3 is the solution to this system of linear equation. Again, you can go back to the original equation and then substitute 5 for x and 3 for y in both equations.